Alright, welcome to Module 3, Lesson 9, where we're going to be taking our multiplication skills to the next level by learning one more strategy called the standard algorithm. So if you remember back to when we did addition and subtraction, we had a standard algorithm, which just means that it's like the standard method of solving. But it's not the only way of solving, as you've noticed. We've practiced with the area model, we've practiced with partial products, and now this is just one more tool that you can add to your tool belt for ways to solve multiplication problems. So today we're going to be looking at for these first couple of problems what the standard algorithm looks like, how it works, and how it compares to our place value chart. We're going to kind of circle back to that because looking at our place value chart, we can really understand how the standard algorithm works by thinking about how this looks in our place value chart. We can understand the why behind the standard algorithm and not just think of it as steps to follow to solve multiplication. So the first thing I want us to be thinking about, and I'm going to kind of be flipping back and forth here for this first problem so that we can really get an understanding of where we're getting these numbers to solve our problem over here and how it compares to our chart over on the side. So first thing to know about standard algorithm is so long as you perform each of the steps in the correct order, you will get the correct answer. But if you go out of order in any way, it can mess up and affect the final outcome of your problem. So the first thing that we need to do is note that we're going to be taking each one of these numbers times 6. Okay? And we're going to work our way from right to left. So we're going to work our way from the ones place to the tens place to the hundreds place. So with that being said, we're going to do the same thing in our place value chart. We're going to work from the ones place to the tens place to the hundreds place. So the first thing I'm going to show in my place value chart is this 2. So because my 2 is in the ones place, I'm going to have 2 place value discs in the ones place. Now, because I said I'm going to multiply everything by 6, well, 6 times 2, I need 6 groups of 2. So 1, 2, 3, 4, 5, 6. Okay, I have 1, 2, 3, 4, 5, 6. Just double checking. I've got 6 groups of 2. Well, if I count all of those up, 6 times 2 is 12, so I should have 12 place value discs in here. But I know that I cannot keep 12 in that column because if I have a bundle of 10, I've got to bundle and send it over. Alright, so I'm going to look for a bundle of 10. I've got 2, 4, 6, 8, 10. And instead of 10 ones, now I've got 1 10. And I have 2 left over in the ones. So if I come over here to my standard algorithm with my multiplication problem, I've got 2 down here, 2 on the bottom, 6 times 2 is 12, but I had to bundle and send a 10 to the tens column. So I had to send it up top. Okay, now I'm going to come back to my tens column, and I've got to start with my 6, so I've got 1, 2, 3, 4, 5, 6, and I'm going to go ahead and put that 1 in there so that I show that I have, here's my original number, 162. That way we don't get confused. So 162. And I'm going to multiply this by 6. So that's one group of 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's 6 groups. 1, 2, 3, 4, 5, and 6. Okay, I do have 6 groups. Now I know 6 times 6 is 36. So I technically have 36 in this column, but I know that's way too many. So I know that I can get some bundles of 10 out of here, and I know that this 3 right here gives me a clue that I can get 3 bundles of 10. So I've got, let's work through here. So 6, 7, 8, 9, 10. This is where it gets a little bit messy here. We've got 2 plus 6 is 8, 9, 10. 4 and 6, 10. Okay, I think I've got my 3 groups now. So I'm sending those over as 300s because 10 tens equals 100, and I had 3 groups of those. So I come over as 300, and I have 6 left over, which makes sense here. But then I can't forget, and it's kind of hidden in there, but I brought 1 over, so I actually have 7 in the tens right now. So I have 7 left over because I sent 30, or I'm sorry, I sent 3 groups of 10, 3 groups of 10s over to the hundreds. So let's come back over to our multiplication problem. So 6 times 6 is 36 plus 1. I'm going to add that. I can't forget that group of 10. I'm going to add that group of 10, and I'm going to get 37. Now, just like I carried my 1 up, I've got to carry my 3 up. So 37 is where that came from. Okay. Last but not least, I've got to take my 1 and make 6 groups. So I'm now taking the 6 times 1. So it's 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. Okay. Can I bundle is my next question. Can I make a bundle of 10? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have a bundle of 10 here, but I do know I have 9 in the hundreds place. If I had 1 more, then I'd have to shift it over to the thousands, but because I've got 9, I keep it the same. And let's see if that matches up over here with our standard algorithm problem. We've got 6 times 1 is 6. 6 times 1 is 6. Plus 3, 7, 8, 9. Notice I've got 972. So when we're thinking about carrying and bringing over for our standard algorithm problem, the key is to remember is that these numbers are because we had to bundle and send over. That's where those came from. I sent 1 bundle over to the tens column, which notice I've got a 1 above the tens, and I ended up sending 3 over to the hundreds, which is why I have a 3 above the hundreds place. So keep that in mind as we continue to move forward with working these problems out, because eventually you don't need the place value chart, but it is important to understand where these numbers are coming from. Alright, we're going to look at one more problem along with the place value chart. This time we have 316 times 5. Alright, this time I'm going to put my whole number in there first instead of doing it one by one. I think it'll make a little bit more sense. So first thing I'm going to do is represent this number in the place value chart. So I have 300 and 1, 2, 3, 4, 5, 6. 1 in the tens, 6 in the ones. Okay. Here we go. I am multiplying by 5, so I need 5 groups. I'm going to start in the ones place. So 5 times 6, I should end up with 30 dots, because 5 times 6 is 30. So I got 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I've got 1, 2, 3, 4, 5. Okay. How many groups of 10 can I get out of this? Well, I know that, let's see, 6, 7, 8, 9, 10. I know I've got 30, so I should have an even amount of groups come out. That's another 10. And then finally, one more 10. So I have 3 groups of 10, which means I'm going to send 3 over to the tens place. So I have nothing left here, and I sent 3 groups over. So if I look at my standard algorithm, I have nothing left, and I sent 3 groups over. So when you do the standard algorithm, if you have a 2-digit number, which most of the time you will when you multiply, your number in the ones place stays down below, and then you carry over the number in the tens place because you're sending those bundles over. Okay. Now we are going to multiply my tens place by 5. So I've got 1, 2, 5 times 1 is 5, so I should have 5 here. 1, 2, 3, 4, 5. I've got 5 groups of 10. And now I've got to think, do I need to bundle? So I've got 5, 6, 7, 8. In this case, I don't need to bundle because I don't have 10, so this is 8. So let's check that over here on our chart. We've got 5 times 1 is 5, 6, 7, 8. So nothing came over. I don't have to worry about that. Alright, last column here, our hundreds, multiply by 5. Well, 5 times 3 is 15, so I should have 15 groups, I'm not 15 groups, I should have 15 place value discs with my 5 groups. So I've got 1 group, 2, 3, 4, 5. Now if I count them, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just like I thought. 3 times 5 is 15. Okay, well I know I can get a group of 10 out. Send over my 10. Gotta make a kind of a makeshift column here, but I know that this is the thousands place. Bring it over to the thousands. I have how many left over in the hundreds? I have 5. Well, 3 times 5 is 15. Carry my 1 over. And it ends up coming down here. And I've got a 1 in the thousands place. So notice 1,580 for both my standard algorithm and my place value chart. Alright, we are going to now do a problem. We're going to let go of the place value chart now that we've seen how that works, and we're going to compare partial products to standard algorithm. So first thing I want to work out is the standard algorithm problem. So follow along with me, that way you can get in the practice of what this looks like. The only difference once you get to, let's say, a thousands number is you just have one more place value you have to multiply by. Okay, so again I do the ones place first. 5 times 7 is 35. Bring over those bundles so they come up on top. 5 times 3 is 15. And then I need to add the 3 in. Don't multiply that in, add them. So 5 times 3 is 15, 16, 17, 18. Carry my 1. Remember, that's going to be added, not multiplied. 5 times 2 is 10, plus 1 is 11. Okay, now let's solve that with partial products. So we've got 237 times 5. Now remember, this is what we did in our last video, so this should look familiar to you. This is a 7. This is not a 3, it's a 30. This is not a 2, it's a 200. Excuse my handwriting. Okay, 5 times 7 is 35. 5 times, not 3, but 30. 5 times 30 is 150. And 5 times 200, well, 5 times 2 is 10. And then multiply by that 100, I'm going to end up with 2 additional zeros on the end. Add them up. 5 plus 0 is 5. 3 plus 5 is 8. 1 and 1. 1,185. Excellent. Okay, we're going to do one more problem where you're practicing standard algorithm. This is one of those ones where I want you to pause, I want you to practice, and then I want you to come back and check your answer with what I have. I'm going to continue to talk my way through the standard algorithm on this problem, but again, you pause and then you can follow along with me to see if you have come up with the same answer as I do here in just a minute. The problem that we're going to solve is 1,247 times, let's do times 4. Okay, go ahead and pause, complete the problem, and then come back and see me. Okay, I have 4 times 7, which is 28. 4 times 4 is 16. Remember, I add my 2, so that's 18. Carry my 1 because I'm bringing that bundle over. 4 times 2 is 8. Plus 1 is 9. And 4 times 1 is 4. I don't have to add anything because I didn't bring anything over from the last time. So I got 4,988. Now, one thing to think about that's a little bit different than partial products is that this time you're not necessarily multiplying by what the value of that number is, and that's because it kind of takes care of itself as you work along. So the biggest difference between partial products and between standard algorithm is that you're not breaking it into its pieces, because you're already multiplying by each of the pieces of the number, so you don't have to break it apart. But again, whichever one of those suits you best, whatever helps you understand how this process works, is the one I want you to stick with. The last problem that we're going to look at is a word problem, one of those real world problems. And we're going to be introducing this idea of the tape diagram again. So I know we talked about this a lot when we were working with addition and subtraction. Well, it's going to circle back now as we start completing more word problems in regards to multiplication. So the first thing I'm going to do is I'm going to read it. I'm going to pick out my important information. Hopefully you're kind of thinking along with me. Oh, this sounds like it's something I need to remember for solving my final problem. So it says, Isabel earned 350 points while she was playing Blasting Robot. Isabel's mom earned 3 times as many points as Isabel. How many points did Isabel's mom earn? Okay, so here's what I know. I know that Isabel had 350 points. And then Isabel's mom, I'm just going to put an M for mom, had 3 times that amount. And I want to know how much her mom had. How many points did she have? Okay, so let's think about this in terms of a tape diagram. Well, here's Isabel. Here's what she has. So if you think back, what goes inside the tape diagram is the value of that bar. So we know that Isabel has 350 points. I'm going to make my bar just a smidge smaller so that I can show this correctly. So she has 350 points. We know her mom has 3 times that amount. So that means she's got what Isabel has, but she has it 2 more times, because she has it 3 times. She has 3 times what Isabel has. So 1, 2, 3. Well, if she has what Isabel has 3 times, I can assume that each of those boxes that represent Isabel's mom have that 350 point value in them. Now, I could add these up. I could do repeated addition, but that might take me a while. I want to practice multiplication. So if I think about her mom having 3 times the amount that she did, I'm thinking I can solve this with my multiplication. So again, we're going to practice that standard algorithm. So practice along with me here. We've got 3 times 0 is 0. 3 times 5 is 15. I'm going to carry that 1 because I'm bringing the bundle over. 3 times 3 is 9. Plus 1 is 10. And I've got comma in there. So I'm showing that Isabel's mom had 1,050 points. Now, if you had gone on and you've added 350 plus 350 plus 350, you added them 3 times, because we know that's what we represented in her mom's tape diagram, and I added those up, 5 plus 5 plus 5 is 15. Carry the 1. 1 plus 3 is 4. 5, 6, 7, 8, 9, 10. Notice you get the exact same answer. Okay, so that's a good way to kind of check yourself. But again, as we get to bigger numbers, that's not going to be the most time-efficient strategy for you. But know that that's a good way in the end to see if you did your multiplication correctly. All right, this is where I leave you today. We're going to continue working on standard algorithm as well as that those partial products and your area model, and we're going to tie those all together. As we move forward, we're going to be solving some more word problems, so be ready for that. And good luck, as always.